This Pro One comes to us from none other than Rico Conning. Rico Conning is an English musician, singer, songwriter, producer, engineer, remixer, and sound designer. He may not be a household name, but I'll wager if you've spent any time in the last 40 years listening to the radio or out there on the dance floor, you've heard his work. Rico's love of music was forged in the crucible of the post-punk era. He quite literally attended high school with none other than Ian Curtis. His band, The Lines, was signed to Red Records, and in 1982, he, William Orbit, and Laurie Meyer established the Gorilla Studio, pictured above, circa 1984, where Rico established himself as an engineer. This early picture of Gorilla predates subsequent leveraging of a recording contract, which funded the acquisition of a 24-track and other gear that helped attract a who's who of the post-punk, proto-industrial scene growing around London and the rest of the world. Not soon after, Rico engineered what has long been one of my favorite records of all time, Colorbox's self-titled LP. Colorbox was the name given to two brothers, Stephen and Martin Young, who had come to fame after signing to Eva Watts Russell's 4AD label. It contributed significantly to the sound of This Mortal Coil, including the 16 Days Gathering Dust medley that formed the A-side to Song to the Siren, the album It'll End in Tears, and Filigree in Shadow. They released their own singles and then, in 1984, recorded this album. To set the scene, in 1984, the MIDI standard had been finalized and the new MIDI-capable instruments, like the Yamaha DX7, the Roland Juno 106, were coming onto the market. Sampling was in its infancy, and the Ensoniq Mirage, the first semi-affordable prosumer sampler, was released. It was the height of Thatcherism, a miners' strike had paralyzed the country, and bands like Art of Noise were busy in another part of town recording their first record with Trevor Horn at the helm. Colorbox came into Gorilla, and with Rico Conning manning the desk, produced an album that was groundbreaking in its use of technology. One part dub, one part cut-up spaghetti western. The record, which I heartily recommend, was both a technical and artistic masterpiece. It cleared the path for what would sadly be the Young Brothers' final musical chapter, when 3 years later, in 1987, they collaborated with A.R. Kane under the name Mars to release Pump Up the Volume. Music and music making would never be the same. Sadly, the world wasn't ready for sample-based music, and the flurry of lawsuits that followed Pump Up the Volume, which had incorporated more than 30 samples before sample clearing was even a thing, forever poisoned the Young Brothers, and they stopped producing and never worked with 4AD again. Rico was there at the beginning, and his contributions to the success of Colorbox and Gorilla's other clients were increasingly recognized and in demand. While he, Laurie Meyer, and William Orbit worked on their own projects, both independently and together as members of the band Torch Song, Rico worked with a dizzying array of clients as producer, engineer, or remixer for the likes of Depeche Mode, Bassomatic, Erasure, Bomb the Bass, S-Express, Baby Ford, Martin Gore, Renegade Soundwave, Laybach, Coil, Test Department, Swans, Wire, Ya Wobble, Robbie Williams, Madonna, U2, and Sting, Dusty Springfield, and a whole lot of French artists whose names I simply cannot attempt to pronounce. In the 90s, Rico moved to Los Angeles and established the sound design company M62, while sober. It's in this capacity that while working for clients such as BMW and Nike and remixing bands like Front 242 on the side, that our current subject, the Sequential Circuit's Pro One, found its voice. Somewhere along the way, the Pro One's keyboard gave up the ghost, and Rico converted it to be used as a CV-controlled module. He warned me, and he was right. When I got the Pro One, it was in about 200 pieces, and not all of it was there. But have no fear, we're committed to getting this thing working again. Those of you who are regular viewers will know what kind of love I have for this gear, and although I'm not one to wax metaphysical, if there was ever an instrument that might hold some special mojo, the Pro One might be it. Let's just say it has a unique spiritual side, or inside. More about that. The Pro One is a digitally controlled analog synthesizer, and the brains of the operation is the Intel 8021 8-bit microcomputer. The 8021 contains a whopping 1 kilobyte of 8-bit ROM, mask programmed at the factory with the instructions required to control the synthesizer, and 64 bytes of dynamic RAM, which is used to track key presses and contains the sequence information for playback through the onboard sequencer. With each read cycle, the microprocessor scans the matrix of switches established by the keyboard and the mode switches. With each key press, the CPU generates a unique 6-bit binary number that's sent to the analog device's 8055-8 digital to analog converter, or DAC. The CPU determines which is the lowest, last note to be played, then adds 12 to the key number and sends this 6-bit binary number to the DAC in parallel. The DAC is scaled such that it provides exactly 1/12 of a volt per semitone to correspond with the 1 volt per octave scale. The advantages of this system, compared to the voltage divider network that's typical of earlier keyboards, is that the accuracy of the control voltages generated depends only on the scaling and operation of the DAC itself, rather than the sum of several independent errors resulting from a network of resistors and the resistances of the key contacts themselves. As such, a properly tuned Pro 1 should exhibit superior keyboard scaling compared with an MS-20 or an ARP Odyssey, for example. Once the DAC generates the pitch control voltage, that voltage is further processed, depending on the glide settings, in a manner that allows for the smooth, controlled transition from one note to the other to effect portamento. The microcomputer is also responsible for generating gate and trigger signals in response to the keyboard, sequencer, arpeggiator, or external clock signals. The trigger signal occurs briefly when a key is first played, while the gate signal is held until a key is released, which starts the release portion of the envelope generator. The main LFO in the Pro 1 is a CEM3340, the same type of chip that drives the two main oscillators A and B. It provides sawtooth, square, and triangle-shaped waveforms that can be summed and sent via the modulation routing matrix, the array of switches on the left side of the instrument, as one of the 3 modulation sources to any combination of oscillator A, B, or the filter. As we'll see in a moment, oscillator B can also be set to low range, where it functions as a second LFO and can be similarly routed through the modulation matrix. Oscillators A and B are provided with the sum of 4 control voltages. First is the main keyboard pitch CV generated by the DAC, which is nominally 1 volt for the lowest key, C1, and 4 volts for the highest note on the keyboard. Added to this is the voltage established by the octave switch position. No voltage is added for switch position 0, 1 volt for position 1, 2 for position 2, and so on. The master tune knob and pitch wheel voltages are also added, with the pitch wheel set at 0 volts when in the middle position. The CEM3340 takes the pitch CV and generates 3 waveforms: sawtooth, square, and triangle. Oscillator A is configured such that the sawtooth and square waves are available, and the square wave can be modulated by pulse width modulation. The triangle wave of oscillator A is used as a source for the switchable hard syncing of oscillator B. Oscillator B is configured to utilize sawtooth, square, and triangle waveforms, and has the additional feature of being switchable to a low-frequency range, where it can function as an LFO and keyboard tracking can be switched off. Similarly to the LFO, the waveforms generated by oscillator A and B can be summed in any combination. Prior to being sent to the filters, the signals from oscillator A and B are mixed with either a noise signal generated by a reversed biased PNP transistor, Q103, or an external audio signal patched in from the front panel that in turn drives an envelope follower. The core of the Pro 1's filter is a CEM3320 VCF. The 3320 is a 4-pole filter chip with each 6 dB per octave filter configured in series to provide for 24 dB of low-pass resonant filtering. The 3320 is followed by a TLO82 op-amp that feeds back into the filter to augment the filter gain at low frequencies and compensate for a loss in low-frequency gain when the filter is oscillating. The filter cutoff frequency is controlled by the cutoff frequency knob, but is also controlled by various modulation sources in response to the same 1 volt per octave scaling that affects the VCOs. After leaving the filter and the filter buffer, the signal is processed by the voltage-controlled amplifier, or VCA, which is 1/2 of an RCA CA3280 operational transconductance amplifier. As OTAs are actually responsive to current rather than voltage, the VCA control voltages are first converted to current by the PNP transistor Q104. Both the voltage-controlled filter and the voltage-controlled amplifier are controllable via the independent envelopes generated by a pair of CEM3310 ICs. The circuitry around these envelope generators is identical, giving each envelope similar timing and response characteristics. This brings us to the Pro 1's power supply, an area that required some revision after the Pro 1 was first released, and where I have some remaining concerns in spite of those revisions. The Pro 1 has a linear power supply that generates 4 power rails of plus and minus 15 and plus and minus 5 volts. This uses an AC power transformer with configurable primary windings, allowing for use in 240 volts and 120 volt markets. This is followed by a full-wave bridge rectifier, reservoir capacitors, and LM78 and 79 series voltage regulation. Early Pro 1s had the heavy power transformer and the power switch mounted directly to the PCB, which caused issues as a result of the mechanical stresses placed on the board. Subsequent revisions moved the primary elements of the supply, the transformer, power switch, and fuse holder, to the rear panel of the instrument. Although this is a big improvement, I still have issues with the power supply in the Pro 1. In the first case, the main filter capacitors, rated at 25 volts, which I regard as too close to comfort to the 22 volts or so of rectified DC they're exposed to constantly, are radially mounted to the underside of the PCB. They don't have any mechanical support other than that provided by their soldering, and indeed, when this Pro 1 arrived, sure enough, one of the capacitors had broken right off the PCB during shipping. Another issue I have with the power supply is the wiring of the fuse, which is on a different pole than the single pole switch. Best practice would be to wire the supply so that the hot lead is both fused and then switched, while the neutral line is connected and not switched. My final criticism is that all 4 voltage regulators rely on the PCB alone for cooling and are mounted on the surface of the PCB that is adjacent to, but not touching, the metal front panel, thereby limiting the air circulation. In my mind, the power supply is a mild distraction from an otherwise beautiful design. In an ideal world, sequential circuits might have mounted the power supply on an independent PCB, used axially mounted reservoir capacitors secured by tie-downs, and incorporated heat sinks for the voltage regulators. The fact that that was not done is probably evidence that Sequential was doing everything they could to keep the Pro 1 at an attractive price point, a gateway drug for future synth. One thing's for sure, I'm hooked. It's impossible to discuss the design of the Pro 1 without discussing the role of the CEM chips, the designation given to the integrated circuits made by Curtis Electromusic Specialties. Doug Curtis was the founder of Curtis Electromusic, where he developed a family of integrated circuits for electronic music synthesizers and audio equipment. He attended Northwestern University, majoring in radio, TV, and film. Shortly after graduating, he entered a competition designing custom chips sponsored by Interdesign, a custom chip manufacturing company in Silicon Valley. To attract entrants, Interdesign had offered to manufacture 100 copies of the custom chip of the winner's design, and Curtis was working on a new synthesizer, and he'd benefit from a supply of custom chips if only he could get them manufactured. His entry into the contest was so impressive, he not only won the competition, he was promptly offered a job at Interdesign and moved to California. He spent 4 years there before launching Curtis Electromusic Specialties in 1979. Curtis's first series of chips, the CEM 3310 envelope generator, the 3320 voltage-controlled filter, the 3330 voltage-controlled amplifier, and the 3340 voltage-controlled oscillator, are iconic to this day. They were known for their sound and improved temperature stability when compared to synthesizer circuits based on discrete components. They can be found in several of the classic analog instruments of the era, including the Roland Jupiter 6, SH-101, MC-202, MKS-80, the Linn drum, the Oberheim OB-8X, the OBXA, the OB-SX, the OB-1, the Memory Moog, the CMI Fairlight 2, the PPG Wave 2, and they could be said to have defined the sound of sequential circuits, as they were a core component of not only the Sequential Pro 1, but the Prophet 5 Rev 3, the Prophet 600, the Prophet 10, Studio 440, and the T8. Many later Curtis chips found their way into other synths made by these manufacturers, as well as those of Ensoniq, Korg, Krumar, Rhodes, and Akai. And in fact, it may not surprise you to learn that even modern synthesizers contain CEM chips, such as the Behringer Neutron, which was released in 2018 and contains a 3340 VCO. The chips are so iconic that since the original patents protecting their designs have expired, other manufacturers have released copies. Cool Audio produces the V3340 and the V3320, AS Alpha Repar released the AS3310, the AS3320, AS3330, AS3340, AS3345, and the AS3360 in dual line and surface mount packages. Happily, these chips can be procured today, helping to ensure a long life for all the synthesizers that rely. A look inside the Pro 1 wouldn't be complete without addressing the drawings on the PCB. The Pro 1's PCB is a two-sided board, and the designers at Sequential took advantage of some of the unused real estate on the component side to locate what might loosely be called decorations. In the first case, we have what's been referred to variously as either a mandala or Buddha image, but it's actually neither. The image is a representation of Shenrezig, a figure in Tibetan Buddhism known as a bodhisattva. The term has two primary meanings in Buddhism. One is of someone who is dedicated to becoming a Buddha. The other is of someone who deliberately refrains from becoming a Buddha in order to focus on helping others. Shenrezig is considered the patron of Tibet, and in fact, the living Buddha, the Dalai Lama, is believed to be an incarnation of him. Another drawing on the PCB is towards the top left, where the Tibetan writing depicts the 6-syllable mantra, Om Mani Padme Hum. This mantra is particularly associated with Shenrezig, and it is the most common mantra in Tibet and an ever-present feature of the landscape, commonly carved onto rocks, painted on the side of hills, or written on prayer flags and prayer wheels. The middle part of the mantra, Mani Padme, is often interpreted as meaning the jewel in the lotus, and the lotus is a symbol signifying purity and awakening, and it's also a component of the third drawing on the PCB towards the middle top, which also features some quite specific mushrooms. The mushrooms in question are quite obviously depictions of Amanita muscaria, often depicted in folk and pop culture and easily recognizable by their white polka dots on a bright red background. Amanita muscaria are the psychoactive mushroom responsible for the myth of the flying reindeer, Santa's red and white suit, and even form the basis of much of Lewis Carroll's story Through the Looking Glass. I reached out to Sequential to ask them about the inherent symbolism on the PCB. Neither Andrew McGowan nor Dave Smith himself could recall much, but they reached out to Denny Samard, Sequential Circuit's drafting manager from the time the Pro 1 was made. He recalls, and I quote, that the Tibetan influence definitely came from Chet Wood. None of the other Letraset art had any significance. It was just there because we could, for fun. Basically, I allowed anyone in my department to contribute. I think the mushrooms were contributed by Greg Armbruster. For reference, Chet Wood was an engineer with Sequential who also worked for many years as a technical assistant and engineer with the minimal musician Terry Riley. He and Dave Smith were the authors of the 1981 paper, Universal Synthesizer Interface, that subsequently provided the basis. So there you have it, a detailed look at the inside of the Sequential Circuit's Pro 1. We'll finish off the video with another detailed flyby of the board, featuring the music of Brooks Mosher. Brooks Mosher is a talented musician who's recorded on Dolly Records, Photic, Comfortable Records, Release Sustain, and Smart Records, a former member of the Intellinet family. We're going to hear one of the tracks off his second Smart release, titled Ascension. The track features a Sequential Circuit's Prophet T8, the big granddaddy of all the Prophet synthesizers, and my personal favorite analog polysynth. The T8 contains no fewer than 16 CEM3340 VCOs, the same chip as in the Pro 1, and 8 CEM3372 signal processors. You can check out Brooks on SoundCloud or find his records on Bandcamp. Links will be in the video description. I hope you've enjoyed this video. We're not done with this Pro 1, and future videos on the channel will describe the cleaning and refurbishment of the key bed and a series of preventative maintenance steps that will ensure this instrument works for years to come. Stay tuned, and thanks for watching.